ESA's new Sentinel-3 satellite will soon be put into orbit where it can start collecting Earth observation data. Measuring ocean surface topography, sea and land surface temperature, and ocean and land surface color, it will greatly contribute to the European Commission's Copernicus program for Earth observation. Despite being the third satellite in the Sentinel family, Sentinel-3 is a rather special satellite with different applications and a different multi-instrument payload when compared to its brothers and sisters.
Sentinel-3 is special in many respects. First of all, we have quite a special payload. We have 3 different instruments, quite in contrast, for instance, to Sentinel-1 and Sentinel-2. And as a consequence of that, we have a large variety of different data available that will cover a large variety of applications, which is for operational applications, so for instance for the Copernicus core services, but also for scientific applications. So we cover quite a large range.
Sentinel-3A is a stunning piece of technology, combining new technologies with so-called proven technologies, which have been tested on pioneering ESA Earth observation missions such as ERS-2 and Envisat. One of the main instruments on board of the Sentinel-3 is the Sea and Land Surface Temperature Radiometer, or SLSTR. It has been based on the Envisat satellite's radiometer, and it's used to measure sea and land temperatures up to an accuracy higher than 0.3 Kelvin. The radiometer, with its characteristic banana-shaped baffles, measures in 9 spectral channels and has 2 bands which are optimized for monitoring fire, such as bush or forest fires. Another instrument with a heritage is the synthetic aperture radar altimeter. It's used for measuring topography over sea ice, ice sheets, rivers, lakes, and also sea levels. It's an improvement on the Cryosat's altimeter. However, what makes the Sentinel-3 so advanced is its multi-instrument payload.
By combining also with the measurements of the other instruments like OLCI, which is on top of the satellite and analyzes the color of the surface of the Earth, it is possible, for example, to determine the constituents in the ocean and the flow on the ocean, like presence of algae, chlorophyll, pollution, and how all these constituents move around the world.
The Sentinel-3 mission consists of 2 paired satellites, Sentinel-3A and Sentinel-3B, with Sentinel-3A being launched first, only to be complemented later by Sentinel-3B. Although they can operate over land, their primary focus will be on the oceans. Although there have been other ocean observation satellites, the technology and the project of Sentinel-3 has some important advantages. First, the Sentinels have a faster revisit time, so they can cover the oceans in just 2 days, a great improvement compared to Envisat, for instance.
Will also be better because the previous satellites were providing granularity, resolution at 1 kilometer. On Sentinel-3, depending on the frequency of the wavelength of the data, we will be able to go down to 500 or even to 300 meter resolution, which for a global mission is extremely important.
With all these improvements, the user community anxiously awaits the first data from the Sentinel-3 satellites with high expectations. Once again, ESA is working on the cutting edge of satellite technology, and after years of research and development, it proudly presents the Sentinel-3 satellite, sending it into space to keep mankind safe on the ground.